Okay, so scientists make measurements all the time. When you were in chemistry, you measured the mass of matter, you measured the volume of liquid in milliliters. We make measurements all the time in science.
Mhm.
So the big thing here is the physical quantity that's being measured. So with physics, we're going to measure length a lot, mass and time, and then whatever else we're studying at that moment. So here, everything is based off of the SI system, the metric system, the SI system. So in this case, our three big base units for this course will be the meter, and we know that the physical quantity is length, the unit is meter. We have the kilogram, which we know the physical quantity in that case is the mass or the amount of matter. And then we have the second, which we know in that case the physical quantity being measured is time. So these are our big three base units that we're going to use in this course. And we can combine these. For example, we're going to learn about speed. And speed is measured in meters per second. So you can see we've taken these base units and we combined them, and that represents our units for speed or velocity. Okay. So I know in chemistry you learned about sig figs. You can tell me that if we have a measurement of 1.004, let's say grams. If we have a measurement of 1.004 grams, you can tell me that that is four significant figures. Or if we have a measurement of 0.01 grams, you can tell me that that measurement only has one sig fig because those leading zeros are not significant. All right, we're going to talk about in physics the how and the why. Okay, so we know that significant figures are those digits in a measurement. That's really important. Sig figs are really important to measurements. Okay, if we're talking about adding 2 plus 2, sig figs are not a big deal unless those are measurements, 2 centimeters plus 2 centimeters. Okay, so those digits that we know for certainty plus one more estimated or uncertain digit. So for example, we want to measure the length of this line. So in this case, the physical quantity that's being measured is length. And we're going to measure that length in centimeters. I know that's not our base or our SI unit, but we can always convert centimeters into meters. So assuming that this line starts at the beginning, okay, I know it's not drawn like that, but assuming this line starts at the beginning, what would be the length of this line using correct number sig figs? So first of all, looks like our line is right in front of that 5 millimeter mark. So we know 42.4. Those are our digits that we know for certain. Okay, we know 42, and we know since that line goes right in front of that 5 millimeter mark, we know it's going to be 42.4 something. Our last digit is our estimated or uncertain digit. Now this can vary between people, okay? In this case, I'm going to say 42.49. And then, of course, don't forget units. In this case, we're measuring in centimeters. We can always convert to meters, which is our SI base unit. The 9 in this case is our uncertain digit. And notice that that uncertain digit is in the hundredths place. You should also be able to tell me that this is 4 significant figures, that this measurement has 4 significant figures. Okay, so we have our certain digits, our uncertain digit, right here, our estimated digit, 4 sig figs, and don't forget the units, and that we're measuring physical quantity length. Now, why do we care? All right, why do we care about sig figs? It has to do with precision. Now, there's 2 definitions for precision. One has to do with a group of measurements and how those measurements are close to one another. We're talking about the other definition for precision, which is if you're looking at a single measurement, how precise is that measurement, the degree of exactness that that measurement is made and stated. So we have 2 meter sticks here. You can see here we have 1 meter stick that has just the centimeter markings. And then here, this meter stick has the centimeter markings, but in addition, it also has the little millimeter markings, okay? So let's say I wanted to measure the length of this line, again, assuming that it starts at the beginning, using this top meter stick, okay? So we know 92 with certainty. Notice because we don't have the millimeter markings, our estimated digit is now in the tenths place versus the hundredths place. So we know with certainty 92, our estimated, let's say, would be 4. And then, of course, we have to include our units. So in this case, the length of this line, assuming that it starts at the beginning of this meter stick, would be 92.4 centimeters. Our uncertain digit is in the tenths place. Okay. Now let's measure this line down here, again assuming that the line starts at the beginning. We know with certainty, it looks like this goes right past this like 7 millimeter mark. So we know 51, and we know since it goes a little bit past that 7 millimeter mark, we know 51.7. These are the digits we know with certainty. So our estimated digit, again, this could vary between people. Let's say 51.72 centimeters. Now our estimated digit is in the hundredths place. And instead of having 3 sig figs like we do here, now our measurement has 4 sig figs. So which measurement is more precise? Well, obviously, it's the one with more sig figs. This depends on the instrument that's being used. Okay? The number of sig figs, the amount of precision that a measurement has, depends on the instrument that's being used. This meter stick is more precise than this meter stick. So when I see a measurement made by a student in the lab, I can tell a little bit about the instrument that was used to make that measurement based on the number of sig figs, based on the precision of the measurement. Okay, let's just try a couple of examples. So in this case, what is the length of this line? And we want it in centimeters and in meters. So in this case, we know 6 centimeters. It looks like it's right in front of that 4 millimeter mark. So we know 6.3. With certainty, we know 6.3. And then our next digit would be our uncertain digit. So let's say 6.38. Okay? And then, of course, centimeters. So this would be our uncertain digit in the hundredths place. Now, if we want to take 6.38 centimeters and figure out or express that in meters, we can use dimensional analysis. We can use dimensional analysis to convert anything. So we want to get rid of the centimeters. We want to go to meters, and you should know that there are 100 centimeters in 1 meter. You could also express this as 10 to the 2. So what we're going to do is we're going to take the 6.38 and divide by 100, or 10 to the 2. We're going to move our decimal place 2 places to the left. So if we were to express this in meters, that would be 0.0638 meters. Notice I have 3 sig figs here. How many sig figs do I have here? Well, it's still 3 sig figs because this leading 0 is not significant. All right, one more thing. This is the picture of a triple beam. And we use triple beams to measure mass. That would be our physical quantity. And then we know we measure mass in kilograms. That would be the SI unit. Now, it's going to ask us in grams, but then we can always convert to kilograms. So with the triple beam, we know 300. We know 370. Looks like it's 373. And then it looks like it's right in between those 2 marks there. So 373.3. Those are our digits we know with certainty. So 373.3, let's go 4. That would be our uncertain digit. And again, it's in the hundredths place. So our answer here is 373.34 grams. That's the mass of this object in grams. And if we wanted to convert, we can just do dimensional analysis. We want to get rid of the grams, go to kilograms, and we know that there's 1,000 grams in 1 kilogram. Or you could express this also as 10 to the 3. So we're going to divide by 1,000, so we're going to move our decimal 3 places to the left. How many sig figs do we have here? We have 5 significant figures. How many sig figs do we have here? We still have 5 significant figures. Converting something should not change the precision of the measurement, should not change the number of sig figs.